the 12 meeting? No, the 13, isn't it?
Oh, is it 13?
Oh, yeah. No, because I didn't receive any point for the 12, but I remember that for that one, I just fall asleep. So, yep, it doesn't count to me.
Okay, cool. So is everyone at the quiz or test?
Yeah, I think I was. What is that sound?
What's the right way? Okay. Yeah.
Someone flying an airplane?
Not me.
Ahorita voy a estar ahí toda la noche. Okay, cool. So question, I guess, number 3.
Yeah.
I can go ahead and start reading that one. So that one says, in an ANOVA hypothesis test, we reject HO when there is sufficient evidence to indicate at least one mean is different from the others.
True, right?
Yeah.
Okay, sorry guys. I think I had you on mute.
Oh, you're funny.
Wow.
I've been talking this whole time. Okay, cool. So just let me know when you're ready, and then we can start.
Yeah, well, you just read the question number 3, and they said that it was true, and I think everyone agreed.
Yes.
Uh-huh.
Okay, cool. Someone want to take number 4? I'll go ahead and read that one. Question number 4 says, what requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply.
For me, only the third one.
Only the third one?
Mm-hmm.
But isn't it the data must be normally
I have the last 2.
and the variances are equal? Because it said it has to be central limit theorem or normal. And then the variances needed to be equal.
Yeah, that's what I
have as well. The last 2.
Okay.
Is that Baja Blast you got?
No, pink lemonade.
Oh.
Want me to read question 5?
Please.
Okay. To check if each group is normally distributed, do the following.
Isn't that QQ plot?
Yeah, that's what I put.
Same here.
Same here.
All right, I can read question 6. We assume the variance in each group is the same if the following happens. Isn't that the largest variance is less than 4 times?
Yeah.
Yes.
Mm-hmm.
So number 7, an ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples?
4?
That's what I put.
Yeah.
I put 6.
6?
Yeah, but I don't remember why. Let me check on my notes.
Yeah, I wasn't sure if that was a trick question or not. I feel
like it is. It says there's 3 samples, which are 3 paired.
So if there's 4 samples, it would be 4 pairs, right?
That makes sense.
That's how I explained it to myself.
I think it's 6.
6?
Why do you think it's 6?
Intuition.
Because it says that it says if you read it, then you see that hypothesis test is equivalent to conducting independent two-sample tests between every part of samples. And then you say if there are 3 samples, then there's 3 pairs. And then so I just get anyway. So my husband already sent me his quiz, and he put 6, and it's good.
Oh wow!
But how?
I was trying to explain you, but I get in a mess. So let me see again. I think I will use a formula for that one. Because the ANOVA hypothesis. If you can keep going with the next answer, and I will just try to figure it out here.
Okay.
Sounds good. Okay, question 8.
Yeah, so we get 4 too, but then his group meeting, one of the ladies say 6, and then they submit the thing, and that one goes wrong in my husband.
That makes sense
so
now.
He changed it, and then he get it right.
It makes sense now because you think about it. 1, 2, 3. You can only get 3 pairs. 1 and 2, 1 and 3, and 2 and 3, and all of the numbers have been touched. But then if you go 1, 2, 3, 4, there's 2. Then you go 1, 3, 2, 4. Then like 4, 1, 3, 2. 6 pairs.
Oh, okay.
Yeah.
Yeah.
Okay. Feel less crazy.
Okay. So everyone is fine now?
Yeah.
Barely.
Yes.
Sorry.
Thank you.
Okay, question 8. The data in soccer shoes was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, and E, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target, so smaller numbers are more accurate. What is the minimum variance for the 6 groups?
Hold on. I'm trying to do that. Because I don't know for you guys, but for me, it came up in just one big line. And so now I'm copying it to our lifesaver.
Hey, do you see how long is the next group meeting? I mean the group quiz for the next one, the 15.
No.
No.
I usually take it one day.
32 questions.
We're going to die.
Why? Why is it that long?
I don't know, but most of them are like simple choice.
Oh, multiple choice?
Multiple choice, yeah, that one. And that makes some of them easy.
Oh, for
that's good.
sure.
Mm-hmm.
Of course, he's like, oh, look, I'm giving them these. Let's just give them more questions.
Yeah, and because we are doing the exam to this week too, so it's gonna be a fun weekend.
Wait, the exam's this week?
Yeah.
Yep.
I am not paying attention that well.
Neither am I. I again, week by week.
Okay, so what did you get in the question A?
Well, I don't know about them, but I'm still trying to put it all into ANOVA. I did just get my last row in though. So now let's look.
Oh, okay.
Looks like variable 3, which was C, with 27.208.
Yeah, that's what I
Uh-huh.
Yes.
get. Good.
Okay, so number 9, what is the maximum variance for the 6 groups?
Hold on one second.
53.158.
Yeah,
That's what I got.
good.
Perfect.
All right. The test for equal variances is satisfied for these data.
It's true.
Well, here. Yeah, it would be true because it's less than 4x.
Yeah.
Here.
Mm-hmm. Question 11. Construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots. True or false?
True.
I agree.
Same.
Hold on, what?
Question 11.
Oh, yeah.
True.
I mean, we could construct a Q plot, or we can just pretend we did. If you perform an ANOVA test, you will observe that the p-value is 0.081. Remove the SOX data and perform the test again. What is the p-value when we remove the SOX data?
Yeah, so just remove the 6th variable.
Mm-hmm.
Mm-hmm.
That puts it at 0.309.
Yes. The test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or left the F statistic?
Right!
Right.
Right.
Yeah, right.
Kelsey beat everyone to it.
Yeah, right.
Studied that one. I may not have done the prep this week, but I was ready with the notes.
That's good.
I'm not paranoid at all again. That'd help.
Question 14. Researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat. Mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available in the file Hot Dog Nutrition. Use the data file to answer the remaining questions. Let's examine the calories first. What?
Sorry, I'm looking at it because I just opened it up and it compares calories and sodium.
We're looking at calories first. That's
Cool.
what the question is going to say.
Okay.
That was just the information. So question 14. I'm sorry, I keep interrupting you.
Oh no, I was just telling you I was panicking until you saved
Okay.
my life and reminded me it was okay.
Let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs and then compare the variances to determine if the assumptions to use ANOVA have been met.
I think that the assumption has been met.
That's what I thought.
Well, that's what I'm going to check super quick.
They all looked pretty equal.
Well, you never know if it's going to make us throw it in. So I'm just trying to cover that all. Alright. Okay. Yeah, if we're just going off the variance, it looks normal.
Okay, so 15 is run an ANOVA test to determine if the main number of calories it is the same for all 3 types of hot dogs. You should find that the degree of freedom are 2 and 51. Then F equals 16.074 and P equal 0.000. with a level of significance equal to 0.05. What conclusion can you draw? We have sufficient evidence to claim that at least one of the hot dog types have a different mean number of calories than another type. That was my answer.
Hold on.
It's the fourth one.
The fourth one here.
I'm looking at level. Where do we see level of significance? Or
0.05
Oh, yeah.
is in the
That's one of the things that he just
question.
gives us, right?
Mm-hmm.
Yeah. We have sufficient evidence.
Beautiful.
I know.
Number 16. Now let's examine the sodium levels. Construct QQ plots of the sodium level for each of these three types of hot dogs. You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is 7180.75 and the largest 10492.871. Have the assumptions been met to use the ANOVA? Or to use ANOVA?
Oh, these are sodium.
For me, it was the third one.
Well, if it's showing us the variant, that's more than 4 times. Because 7.180 times 4.
That's 28,000.
Yeah, it's not even close. The variances are not equal, even if the QQ plots are normal. So I would say the assumptions have not been met. While it's safe to assume each group comes from a normally distributed population, we cannot assume the variances are equal.
I agree.
Okay. So 17.
Okay. 17. Despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the mean sodium levels are the same for all three groups. What is the p-value for this test?
Oh goodness gracious, I didn't type any of that in. The one time I could have been prepared. No. You monster.
I get 0.179.
1 second, and I will see if I agree with you.
Did you get that too, Caitlin?
Yeah, I wasn't sure if we needed to round up or not, though.
For that one, we shouldn't because it's 0.1793, so it won't even round up.
Okay. Yeah, that's the only thing I was indifferent on in that question. Okay.
So last one.
Now, see, this one's like is it just we have sufficient levels to claim that all three hot dog types have the same mean sodium levels, even though they're different? Because if we just look at the p-value and the level of significance, it's over. So normally we'd accept that. But these variances are different.
But if they're close enough, then we don't have to reject them. But I'm not sure.
I put the second one. We don't have sufficient evidence to reject the claim that all three hot dog types have the same mean sodium levels.
I agree.
That's fair, because it's not saying we claim it either. All right, and submit.
Let's see how we do.
Oh, look, I missed one. Oh, no, I missed another one.
Oh, what the heck?
Question 10.
I get the
And 15 and 16.
Oh, look.
I got 15 right. I got 16 wrong though. That's
What'd
my
you
one I
put?
got wrong.
I
For
thought we said we
15?
had sufficient evidence to claim that they have the same mean.
For 15?
Yeah.
For 15, it's the fourth one.
Yeah.
We have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than another type.
Yeah.
Oh.
Mhm.
Then I must not have listened. Let's see, 16.
16, we got the third one.
I didn't put that. I put the assumption have not been met. While it's safe to assume each group comes from a normally distributed, we cannot assume the variances are equal. Is the third one correct?
Yeah, I got a point for that one. First,
Yeah.
16.
And your third one was the assumptions have not been met. It is not safe to assume
Yeah.
each group comes from a normally distributed population, but we can assume that the variances are equal?
Yeah.
Yeah, that one.
And you got that one wrong? That's the one you selected?
No, because I said we
Oh.
cannot assume the variances are equal because 104,000 is greater than 4 times the smallest variance. That's confusing. Okay. I might kick a bishop. Hold on.
You might kick a bishop?
Yep. Okay. Okay. Can someone explain that to me then? Because I thought it was if the variances were unequal, we couldn't accept it. And I killed everyone.
No, that's okay. I just fell asleep for a little bit.
Oh, you're good. I just kind of posed it as a general question, because apparently I don't understand. Let's see. The test for equal variances is satisfied for these data. Oh, I put false for 10. Weird. Construct a QQ plot. Each of the samples, and let's see. 11, 12. Okay, so for 14, it's the third one. It's not safe to assume each group comes from a normally distributed population, but we can assume that the variances are equal.
No,
No.
that's the first one.
What?
Mm-hmm. The assumption have been made.
It's safe to assume that each group comes from a normally distributed population, and we can also assume that the variances are equal.
Mm-hmm.
Oh, I got that one right. Why am I doubting? They're 15. There we go.
And then that one is the last one. And the 16 is the third one.
And how is that? Oh, because it's 0 in the level of significance. Is that so we reject it?
Yeah, the assumption have not been met. So
Okay.
it's not safe to assume each group comes
Well,
from
no, I
a
was on
normally
15,
distributed
saying that because the p value was less than the level of significance, we would reject it. But in this case, it says we have significant evidence to claim that it's different, so it's still that rejection of the null. And then 16, I'm not understanding this one because it tells us what the smallest variance is and the largest variance. Because yeah, that's not 4 times as 104,000 is not only 4 times larger. It's a lot larger. So how is it the assumptions have not been met? It is not safe to assume each group comes from a normally distributed population, but we can assume that the variances are equal. How is it that one?
Did you look at the QQ plots?
Back to ANOVA. File. Open. Descriptive statistics. Nope, that's the wrong one. Was that the wrong one? Is there an easier way than the way I'm about to do it? Because I'm literally just copying it into the quantitative descriptive statistics file.
That's
Okay.
what I did.
Yeah, that's not normal. Just that one alone isn't normal. Okay.
Does that make more sense?
Well, yeah, I think the biggest one that I'm tripping on is that we can assume the variances are equal. Because I thought the variances were only equal if the largest variance was 4 times or less than 4 times greater.
Yeah, and it's not 4 times greater.
But the answer that we picked that was correct says, but we can assume that it's greater. And 780.75 times 4 is not even 30,000.
That's because the data
It's
wasn't normally
10,000.
distributed.
It's 10,000, isn't it?
Yes.
I read it as 104,000.
I think that's what it.
There we go.
That, yeah, I think that's what it was.
Because Kelsey's a little crazy, guys.
Okay.
She's just having a mental breakdown. That's okay.
Oh, you're fine.
Fine.
No worries.
And then we do not have sufficient evidence. Okay, cool. Save. Now let's see, because I know I missed one. Yep, there we go. We're good.
You're good?
Okay,
Sweet.
did you get the 18 right?
Yeah.
Okay. So
Awesome.
we're good to go.
Okay, now guys, who's going to do the next one? And the reason I ask is because play rehearsals are getting later because now we're rehearsing with the orchestra and we're doing mics. And so I don't know what time I'll be back. It'll probably be around this time. So I can launch it if we want to. It just might be a little late.
I can launch it.
Okay.
Sounds
Who was
good.
that? Sorry.
Estrada's going to do Thursday.
Oh, okay. Perfect.
If you have any problems, you can ask.
Seriously,
Well, my husband does the one for the team that so he can help me out. So don't worry.
Okay.
I volunteered him to do it.
Awesome. Perfect. So I'll see you guys on Thursday.
Yeah.
Yep. See you then.
All right. Thank you for your help. Have a good night.
Yeah.
Bye.
Night.
Bye.
Bye.